Lesson 74, Scientific Notation. Let's begin by reviewing exponents a little bit, and we'll look specifically at what happens when we raise the number 10 to various powers. When we raise 10 to any power, we can always write it as a 1 and some number of zeros. For example, a positive exponent will tell us how many zeros to write after the 1. 10 to the third is 10 times 10 times 10, which when we multiply out gives us 1,000, which is written as a 1 with 3 zeros after it. Or another one, 10 to the fifth, that's 5 tens multiplied together. If we do that, we'll get 100,000, which is a 1 with 5 zeros written after it. A negative exponent, on the other hand, will make it very small. It will tell us how many digits to write after the decimal point, including the 1. So it'll be a number of zeros after that decimal point, and then the 1. So for example, 10 to the negative 3, we know we can rewrite that as 1 over 10 to the third, or 1 over 10 times 10 times 10, which multiplies out to 1 over 1,000, which we could write as a decimal 0.001. Notice there are 3 digits after the decimal point, including the 1, 1, 2, 3, because it was 10 to the negative third. This is going to come in handy when we do scientific notation. What is scientific notation? Scientific notation exists and has this name because a lot of times when we're dealing with a scientific scenario, like talking about distance between planets, the weight of very large objects or very small objects, the numbers that we deal with can be difficult to write and confusing. It's easy to make mistakes with them. For example, this number here, 15 quadrillion, is a 15 with 1, 2, 3, 4, 5 sets of 3 zeros or 15 zeros after it. Or this other number, 34 trillionths, 0.00000000034. Trying to write out these numbers consistently and accurately, it'd be very easy to make a mistake, add in an extra 0 or leave out a 0. They're also very difficult for us to say aloud, and so it can be difficult to think about these. Scientific notation is a way for us to write these that's easier to understand. For example, that first number, 15 quadrillion, we can write as 1.5 times 10 to the 16th. Or that second one, 34 trillionths, we can write as 3.4 times 10 to the 11th. Because we have a very easy number to deal with here before the multiplication, 1.5 or 3.4, and then after the multiplication, we always have a power of 10. 10 to the 16th, we know that's going to be a very large number, and 10 to the negative 11th, that's going to be a very small number. And by writing out the power of 10 there, instead of writing out all those zeros, it'll help us keep track of them better. Now, when you see a number in scientific notation, there will always be 2 parts to it. The first part is some number that's at least 1 and less than 10. So this will be a number that only has 1 digit before the decimal point. This will always be multiplied by the second part, which is 10 raised to some power. The power on the 10 will tell us how many places to move the decimal point to get the actual number written in our standard way of writing numbers. If it's a positive power of 10, we'll move the decimal point to the right because that'll make the number larger. Remember that example of 15 trillion, when we had 10 raised to the 15th, it gave us a very large number. Similarly, a negative power of 10 will move the decimal point in the other direction, so there will be lots of digits after the decimal point, and we'll end up with a very small number. So anytime that you have a positive exponent on your 10, you're going to be talking about a large number, and a negative exponent on 10, we're talking about small numbers. It's important to keep those straight. So for example, say this number 4.165 times 10 to the 7th. If we want to write that using standard notation, that 10 to the 7th will tell us to move the decimal 7 places to the right. Because 10 to the 7th, or 10 million, multiplied by this, we can either multiply that up by hand or more conveniently, and the 10 to the 7th tells us we take the decimal point and move it 7 places over to our right to make the number large, because that positive exponent on the 10 tells us we're dealing with a large number. So we could write this as 4.165 with the decimal point here, and then we move it 7 places to the right. So we go 1, 2, 3, 4, 5, 6, 7. And there's our decimal point. We end up with 41,650,000. Let's do one with a negative exponent, 3.16 times 10 to the negative 4th. That negative exponent on the 10 will tell us to move the decimal point 4 places to the left, giving us a small number. We could write that as 0.0001 and then multiply them, or we can just write our number here, 3.16, and move our decimal point 4 places to the left. So this time, to make the number small, we go to the left. 1, 2, 3, 4, and the decimal point goes there. We'll usually write a 0 before the decimal point to make it a bit more obvious where the decimal point is happening. Now, what if we're trying to convert something into scientific notation? Well, first thing we'll do is we'll move the decimal point so that there's only one digit in front of it. That'll give us the first part of the scientific notation. For that second part, we'll count the number of places that we moved the decimal point to get it to a place where there was only one digit in front of it, and that'll tell us which power of 10 to use. Again, depending on which direction we move the decimal point, we'll either use a positive power of 10 for large numbers or negative power of 10 for small numbers. Here's a useful tip. When we're multiplying numbers in scientific notation by powers of 10, we can add the exponents on the tens. So for example, 4.78 times 10 to the 5th, we want to multiply that by 10 to the 3rd. One thing we could do here is we have 10 to the 5th times 10 to the 3rd. Those are like terms. Remember, when we have like terms, or rather the same base, with exponents being multiplied together, we can just add the exponents there. 4.78 times 10 to the 8th. Or another example, 0.00071 multiplied by 10 to the 7th. Here, it'll be easiest if we convert this number to scientific notation first and then multiply by 10 to the 7th. So using our procedure from the previous slide, to convert this number into scientific notation, notice we're going to multiply by 10 to the 7th. We put the decimal point here. Why? Because that will give us one digit to the left of the decimal point. So it ends up as 7.1. Now to get the decimal point there, we had to move it how many spaces? 1, 2, 3, 4 spaces. And this is a very small number, so we know we'll have to use a negative power on the 10. 7.1 times 10 to the negative 4th. Then we'll do what they asked us to, multiply by 10 to the 7th. And to combine these together, because they have the same base, we can just add the exponents. Negative 4 plus 7 will give us positive 3. So our answer in scientific notation is 7.1 times 10 to the 3rd.